Right. Hello, everyone. Welcome to the TensaX Innovation Lab webinar on getting started with artificial intelligence. I'm Dr. Vishu Gupta, Head of Research at TensaX Innovation Lab. And I would like to welcome all of you today. And I know we are joined here today by participants from all over the country. And all over the country and all over the world, actually. We have registered participants from 12 different countries right now. So we're excited that you've joined us today. Our goal here with this webinar is to basically initiate and induct you into the world of artificial intelligence and get you to understand exactly where artificial intelligence is being applied these days. And then, of course, to move on into the basic building blocks of machine learning and how to get that developed. So what we are going to do today is just get on with that. And a few things before we start. If you have any questions at any point, there's a raise a hand option at the bottom of your screen. Please feel free to use that. We're going to have a Q&A session at the end of the webinar. And during that time, we would be more than happy to answer any of the questions that you may have. So now I would like to introduce my co-host, which is Mr. Aryan Singh, Chief Technology Officer at TensaX Innovation Lab. Hi, Aryan.
Hello, and hello, everyone, and welcome all to Getting Started with Artificial Intelligence. I am Aryan, and today I am accompanied by Dr. Vishu Gupta. Artificial intelligence is everywhere, and artificial intelligence's adoption is going to be increasingly growing, and it's going to be a part of every single process that we interact with on a day-to-day basis. It's going to assist, automate, and augment every single process that there is, and it applies to almost all fields. Imagine having an entity that does all the boring and repetitive work for you. It would be a fascinating world to live in, and that's where we are headed. Now, to get into it further, let's define what artificial intelligence is. And to get onto that, let's first define what can we call intelligence. Now, intelligence is the ability for an entity to make sense of its environment, to distinguish, to use reason, to learn, and then to make decisions. And artificial intelligence is the ability of machines and algorithms to replicate that. You may have various ideas of artificial intelligence, and those ideas may look something like this. Haha. These come from science fiction and amongst others. But I don't know if you already know, but you're already surrounded by artificial intelligence and everywhere. So you have all the virtual assistants, Siri, Google Assistant, Alexa, all of them, they're using multiple language models. And you have Tesla with their self-driving cars. You have social media algorithms with their recommendation engines and their facial recognition algorithms. You have all the language models applied with all of the Google products, Google Translate and Google Search. They use a variety of machine learning models. Machine learning is the building block of artificial intelligence. And all of these services use artificial intelligence in their background. Some of these services you may recognize already. You recognize Tesla with their self-driving cars. You recognize Netflix with their recommendation engine, which recommends you content. It understands you, and then it recommends you content based on which content are you most likely to watch next. And likewise, there's Amazon, which they have their own recommendation engine, which recommends you products, and so on. There's so many services and products out there already which use artificial intelligence. And then further down the list, these are the companies which offer services that help in the facilitation of artificial intelligence, the running of the algorithms in the backend. Artificial intelligence is not just limited in it of itself, as in it has practical applications in basically almost all fields. And so here are some more names and logos. Its adoption is increasingly growing into every sector that we know of today. Artificial intelligence it's referred to as the next big thing. Like we have the different industrial revolutions. We had, first of all, mechanization, and then we had factories, electricity, and mass production. The third industrial revolution was the interconnectivity, the internet, and the knowledge base that brought with it, the connectivity that the internet brought. And the fourth industrial revolution is going to be artificial intelligence, the automation of intelligence most precisely. Now, what's going to happen is every single task is going to be helped, aided, and made better with artificial intelligence. Artificial intelligence is going to help people do their jobs better. There are obviously going to be some jobs which are going to be assisted by artificial intelligence. And so the people who may be redundant because of the same, the world is going to head towards something known as universal basic income. We have to be comfortable with the idea that the person whose job is assisted by artificial intelligence, who uses artificial intelligence, or many of their laborious tasks are now done by artificial intelligence, we have to be comfortable with the idea that that person too, they are valuable, and we have to pay them a certain amount of money so that they can sustain and grow themselves. And so AI is going to bring a fundamental change to the economy. It's going to change how at the moment, we trade time for money, and people largely do laborious jobs. Now, all the laborious jobs can be done through artificial intelligence, and people are going to be free to do the things that they desire the most. Be creative, take decisions, create things, do constructive things, and so on. And hence the concept of universal basic income arises. And it's already being tested out in various parts of the world. This adoption of AI, and particularly why it's been increasing, has a few reasons. These in particular, these ones are the most prominent ones. We've had an exponential increase in the computation power that we have available. In 1969, when they sent a rocket to the moon, they had as much computing power as a high school, the calculators that we use for various exams, similar to those. Nowadays, the computational power that we have is exponentially more, and the trend has been that, and it's going to continue on the same line. And likewise, with all of the digitization that's introduced in various processes, we're collecting a lot of data. And following on these two things, there's been an influx of new research, new algorithms that have really their applications in the modern world and can be used to solve various problems. And all of these factors together, they make for a great time. And so has been the observation that artificial intelligence and its applications have been on the rise. Artificial intelligence has been increasingly being used in different sectors. If you can see this chart, and you can see all of the different sectors in which it is already there. These artificial intelligence models can be classified into three broad subcategories. You have something known as artificial narrow intelligence, which means the models that we are interacting with right now. And those mean that this artificial intelligence model, which comes under artificial narrow intelligence, would be able to perform one task, and it would be specialized for that task and would perform that function. Like, for example, Siri helps you to get things done on your phone, and it understands your language, so it does one task. Tesla's AI drives a vehicle, so it does one task, and it's called artificial narrow intelligence. Something that we are progressing into is called artificial general intelligence. That's when a conglomerate of different artificial intelligence models are so complex and are so detailed that it's indistinguishable from a human being. That is when you don't have to specifically train them for one application. It's a general purpose artificial intelligence which you can use for different things. And later on down the line, we're going to head towards something known as artificial superintelligence, where AI is even smarter than that. Largely, we are now at artificial narrow intelligence, and it's predicted that by 2030, we would get close to artificial general intelligence. Now, what this means is basically the future that we see where we don't have a bondage to doing the tasks we don't like, that's basically that future is just coming closer. These are some of the areas in which artificial intelligence is helping us today.
Yes, you know what, how AI works in certain applications that we are using. So speech to text, right? So Google Assistant basically does what? You say something, it listens to it, it manages that knowledge, it executes tasks, and it learns, right? So as a user, what do we see? What we see is that we said something, and then we see whatever we said being executed. What we miss out on is the managing knowledge part and the learning part. So as designers and developers, we see all of this, right? Now, this application that we're talking about here is more focused on NLP, natural language processing, image recognition, and speech to text. Now, let's kind of explore how else we can apply artificial intelligence in different sectors, right? So we have artificial intelligence is applicable in all of these. Entertainment, Aryan already told you about Netflix, and basically all streaming services are using that. Retail and e-commerce, Amazon is a great example. Travel, everybody's searching for travel destinations based on certain parameters. Manufacturing, food technology, everywhere, artificial intelligence can be applied. So what we're going to do now is we're going to kind of evaluate a few of these and see exactly where artificial intelligence is coming in. So let's talk about healthcare first, right? Healthcare is something that everybody has to deal with. Not everybody might like going to the doctor, that's fair, but we all have to at some point. And there is a significant amount of data that exists for all of us based on medical records. That data is something that we can use for implementing artificial intelligence in early detection of ailments, in associated care, in maybe even wearable devices, right? To kind of assist in health deteriorating situations. What do you think, Aryan?
AI can help you with a lot of things. In healthcare particularly, AI can help you in the classification and prediction of diseases. We made a model with a doctor 3 years ago where using retinal scans, you could classify whether you have diabetes or not. And likewise, there are multiple models which are coming out in practical use, which are going to help you identify and get to the diagnosis of various diseases. You can have all of your data analyzed, and it would give you hyper-personalized healthcare, where it could analyze all of your past disease classifications over the years, and it can recommend you what sort of diseases you might have a tendency of developing, or it could recommend you doctors, or it could recommend you different practices or different healthcare professionals. We can analyze the data of where diseases are happening, and based on that, we can predict where diseases would be. AI can help in healthcare in a lot of ways. We'll get into how specifically it can help later in our further sessions later on.
Awesome. So what you're saying, Aryan, is in terms of healthcare, we can kind of work with COVID related data as well. What do you think?
We can actually, yeah. We actually worked with, a while ago, we worked with Dr. Bilal, and we analyzed their data, and we worked to identify hotspots of different diseases and epidemic diseases that spread through mosquitoes or general virals, and we could identify patterns. And likewise, similar process can be done with COVID as well.
That sounds pretty great. This is an application of artificial intelligence that, if we consider our present scenario, becomes really, really important, because COVID is something that's impacting all of our lives right now, and something like if artificial intelligence can make it better, then that sounds fantastic. Another application. Let's talk about another application. What we keep on hearing about is autonomous vehicles, right? Tesla is doing a whole lot of things with autonomous vehicles. But instead of just talking about personal vehicles, let's talk about mobility, right? We all step out into traffic. We all use public transportation. We all maybe even use cycles to kind of, go about the city. So artificial intelligence can play a significant role in all of these areas. Think about it. If you're waiting for public transportation, how many of you have waited for a significant amount of time when it has been late or it has been delayed, and in some cases, unfortunately, it has together just been canceled, right? It happens. But if we have an artificial intelligence-based algorithm that is tracking the live location of public transportation, then we can kind of predict at what time a particular bus or something is going to show up at a location. And this would ultimately overall ease our way of living, ease our way of traveling too, right? And then of course, autonomous vehicles, they're making their way into personal vehicle ownership like anything. And they allow the drivers to kind of relax and enjoy the scene while the car is driving itself. I'm sure everybody's seen that video, the Tesla promotion video, where the driver can be seen climbing into the back and just basically taking a nap while the car is driving itself, which is a very cool bit of technology, but artificial intelligence is what powers that. Another thing that can happen is it can also work with roadway safety, is another thing for pedestrian crossings and traffic management. And also, yeah, parking management as well. This is another problem that we face with smart mobility, with mobility in general, right? You are traveling anywhere and there is never any parking to go to park your vehicle at. So either we end up driving an extra 15 minutes just to find a parking spot, or we essentially leave, right? So if we can kind of develop an artificial intelligence-based application that takes care of that, then that solves our problem. Another aspect that we should think about is that all over the globe, we are moving towards electric transportation. Now, electric transportation is slightly different from what we utilize now, which is we have to get refueled, right? Either petrol or diesel or gas, whatever you would like to call it at your location. But we do have to get that refueled. The difference with electric transportation is that it lets you charge your vehicle. However, it takes a longer time to recharge or to refuel that vehicle. So this management of when to recharge, how to recharge, which area to recharge in is again something that artificial intelligence can take care of. So transportation by itself has so many applications of artificial intelligence that are already in effect, and a lot more of them are being developed. Another thing that we have is artificial intelligence in business and manufacturing. Now, Aryan talked about Industry 3.0, right? Where it was the introduction of the digital realm. We had IT infrastructure introduced and a bit of automation introduced. Now, when we combine that with artificial intelligence, we get intelligent process automation. It's something like an automated email response that you've programmed, right? A customer emails you or a client emails you, and an automatic response goes, "Thank you, we received your email." Now, artificial intelligence can actually read the contents of that email and respond accordingly based on what questions and services they require. So that is something, robotic process automation with artificial intelligence is now intelligent process automation. I think that's something that we can implement in all our workflows, maybe?
Yeah. And that takes us towards Industry 4.0, and artificial intelligence in business is going to unlock the next dimension of value in almost all sectors. One of the biggest areas in which artificial intelligence can add value to a business is in the automation of the business workflow, helping the people do more by taking care of their tasks. This is an example. The one on the left is an example of a document automation. You see a document, but you have to take a few tasks. You generally have to perform 2 or 3 actions after looking at a document. Let's say it's a letter, and you have to, our artificial intelligence can look at the letter and then boil it down to a few 2 or 3 tasks, let's say the red button or the green button or some other option that you can pre-program, and then it can have you get your things done faster. And likewise, there can be multiple language models which automate the communication of a business, like Dr. Vishu mentioned. And it can be automated emails, it could be customer interaction, or it could be the sending of updates or getting details from somewhere, everything included. And there can be more specific specialized examples, like for example, in the healthcare industry, there can be segmentation of images, which helps doctors clean out the images of radiology scans, and likewise. But largely, there are going to be AI tools that are going to help people get their things done faster, quicker, and in a more efficient way, whilst making it easier and more fun. So jobs are going to be fun. AI it's not just mechanical robotic process automation. AI can help us understand the market, and it can help us do emotion analysis. It can help us get feedback from people. This is a project that we developed a while ago. It's an autonomous review system that looks at facial microexpressions, what people are saying. Let's say people are at an event and they say the speakers were nice and the food was truly awesome. We'll get both of these things, speakers nice and food awesome, and we'll give it a rating. Our facial expression recognition model is the world's highest performing facial microexpression recognition model, and we developed it here in our lab in Jaipur. And this project uses 5 models, ranging from facial expressions, what you say, eye contact, body language, speech intonation, and it does an analysis of that, and it presents graphs, and it presents feedback. And we develop such interesting projects at TensaX Innovation Lab.
So one question, Aryan. If we, so what you're saying with the feedback analysis, basically I would not have to fill out a feedback form again, right?
Yeah, very much so. Your feedback would be autonomous and it would be anonymous.
That sounds great. We can honestly tell people what we thought of their services and actually help them improve, right? Instead of giving blank feedback or something that is tailored to sound good. That sounds great.
Mm-hmm.
So let's come to the programs that we offer at TensaX Innovation Lab. So what Aryan talked about is 2 of the products that have been developed here itself in TensaX Innovation Lab. We believe in sharing the knowledge and learning together and growing together. So what we have are 2 programs here called the Learn and Innovate program and the Internship program. Now, how they work is this session today is actually a part of our Learn and Innovate program, a series that we are launching, basically to talk about artificial intelligence and machine learning, and then continue on with understanding of different algorithms, developing them, and learning together, basically. This is also, we can also talk about the internship program that we have here at TensaX Innovation Lab. Right now, due to, of course, COVID restrictions, we've had everything, online, because that's how the world is operating at the moment. However, in the past few years, we've had boot camps and internships that have been organized here. And what we see is, these are a few of the photos that we have of our boot camp and the internship programs. And our interns get to work on, real world applications, develop products that are cutting edge using artificial intelligence. And it's just an all over fun environment where our interns get to, just have fun with us and learn with us. So another program that we do have partnership programs for other interested parties as well. We do have partnership programs for our business associates as well as freelancers that may want to collaborate with us on any projects maybe, or take care of or work with us for a part of the product development. So with this, we kind of wanted to summarize what we covered in session 1, which was our goal here was basically to introduce you, to get you to understand that artificial intelligence is becoming an integral part of every single area. It's not just about robotics as is usually believed. Artificial intelligence is something that everybody and anybody can apply, regardless of which stream you're in. It's something that's important for doctors, for medical professionals, for engineers, and I don't just mean computer science engineers. I myself am an electrical engineer, so it's equally important for me to utilize it for my work. And same with other engineers as well. So, and of course, as we talked about the workflow management, artificial intelligence has applications regardless of which stream your work is in or where your business is. That is something you should kind of, we should all kind of embrace right now. So that was our goal with this first part. And now what we're going to go into is go into machine learning. Now, machine learning is something very cool that basically drives artificial intelligence, right? Aryan mentioned—
Machine learning is the backbone of artificial intelligence. Machine learning is, there are machine learning models and AI model, and AI is an umbrella term for the multiple machine learning models that work together to make an AI piece. Now, in the industry, we have such an approach towards machine learning and building artificial intelligence. We first begin by identifying the problem. And then, like a mathematician, to solve a problem, we first identify all the variables that we need to solve the problem. And then AI models, specific AI models, let's say that apply to a field, we collaborate with industry experts. So if I'm building a model in the healthcare industry, like for example, we are right now building a model with an exclusive data set of 10,000 images to see how AI can be applied to detect COVID through X-ray scans. We are collaborating with industry experts, and likewise, let's say any specific problem, it's important to collaborate with field experts so that you can understand the cause and effect of the data set. Then comes the data set itself. You have to collect data which represents the problem. It has to have the features that represent the problem. Then you start building your model and then you test it out. You train your model and then you test it and you refine it overall. And it's an iterative process. Once you do that, you start to build a model, and your model, when it gets refined over time, you can do something about it. Either you can productize it or you can have it test in different sectors, various number of applications there. Now, let's get into our second session, which is going to be machine learning in action. How does a machine learning model go from its design to its development to its deployment and then its application in the real world? Let's briefly touch upon what it is like to think like a data scientist. And data scientists are these people who look at different data sets, they clean them, they understand the cause and effect. Then they create a machine learning model which fits the features of the data set. And then that model is then used to solve a problem, either to derive analytics or to solve any problem when applied. So when starting with any particular machine learning model, before building it, we have to work on the data. First, we have to collect the data. And the strategy we say is, well, beg, borrow, steal, obviously with consent.
Absolutely. So collecting data is very important, right? Nothing will work if we don't have enough data. So basically, when we talk about data, there's two very important types that we talk about: primary data and secondary data. Primary data is something that you collect yourself. So if you decided to have a survey about what topics we learned today in our webinar, that would be collecting data from all the participants, right? So that would be primary data. Primary data is generally, collected for the first time, and it is the most reliable one because you are collecting it yourself and it is verifiable. Secondary data, on the other hand, is something that you collect from another source. And this is something that most of us have to do because we can't, of course, collect data for everything. So secondhand information or obtaining this data from other sources falls under the category of secondary data. So now the next associated question that comes up is, where do we get this data from, right? So this data, Secondary data, we can, of course, get it from the primary collectors, the people who actually went out and either did the survey, got the data, or they ran tests on a machine and collected certain data, right? We can get them to kind of share their data with us. Another option is to go for online data resources. There are a number of online data repositories and database that we can access that are free of cost, and that let us basically download the data that they have. Another source is, of course, books and published resources. Books and published resources, of course, include conference papers, journal papers, the white papers that industries publish about their technology. It can be a large number of things, and we can utilize this data as well. Then, of course, blogs and websites. Some people, instead of loading their data onto the database, they usually have it on the, they may have it on their personal website or blogs, which we can access. And then, of course, government records. Government records are this great library of data. There's a lot of data there. However, the challenge here is, even though most governments are now switching over to online databases, we do have a challenge with the fact that there is a significant amount that is hard copy version. So it's printed data or handwritten data that we kind of have to translate. So looking at a few sources.
Various sources from which you can get the data. Here are a few websites. So first of all, there's Kaggle. Kaggle hosts competitions, and it has a repository of various databases, and you can go head on to Kaggle and see just how many machine learning competition Kaggle hosts, and it gives you a data set, and you can use those data sets for your models. Next up, you can go to Google Images. Let's say you want to train an image classifier that classifies cats versus dogs. You can go to Google Images, and there's an extension called FATCon Batch Image Downloader, which is shown here on the slide, and you can use it to batch download all the images. India has its own data repository, and it's called data.gov.in. You can request access to private data sets. There are many universities and research institutions which create their own data sets, and you can request to access them. You can do web scraping. There's an extension. You can use something known as Scrappy in Python, or there are alternatively web extensions on Google Chrome, which you can use to scrap data from any web page or a long list or a portal or any other space. Also, you can generate data locally. You can, if you want to click pictures, let's say you want to create a facial recognition system, then you can get people and click pictures, and you can use those images to train your model. To start with it, we have to first clean and optimize a data set, and also understand our data set more. And to understand our data set, we can use something called as data visualization. Now, Dr. Vishu would talk about data visualization a little bit.
All right, so now that you've obtained the data from so many different sources, right, that we talked about, and that specific resources that Aryan mentioned, now that you have the data, you kind of want to analyze it. And data visualization is an important thing. What it does is that it gives you a pictorial or a graphical representation of your data. And it seems like that it wouldn't be necessary, but when you have sheets upon sheets of data, whether in Excel or any other format, it becomes important to kind of analyze what the general trend of that data is, right? So the benefits that we get from data visualization at an initial stage, it lets us identify patterns. It also lets us see if there are any outliers or anomalies within that data set. And then, of course, sometimes initially we're able to see if one variable or one factor is impacting that data more. And then we can kind of analyze what our priority areas may be here, right? But when we're talking about data visualization, what we should look at is how we want to represent our data. Now, what's the purpose of it? Why do we want to showcase this data? What's the goal of showing the data? It could be that you want to show the variation of a particular variable with time. Or maybe when you have 2 or 3 factors, you want to show what their interrelationship is, or just basically compare. That becomes the goal of showing the data. Another factor to consider is the type of data that you have. What is the nature of it, right? Is it time varying data? So temperature throughout the day, that becomes a time varying data. Qualitative or quantitative data, that's another field that we're not going into right now, but that's something that we generally classify the data based on. And then, of course, it's important to understand who you're designing this visualization for, right? So you need to know who your audience is. If it's a product user, or if it's a researcher or a decision maker. And there are, of course, other categories here, but these are the three basic groups of basic questions that you should kind of think of when you try to visualize your data and create a graph or an infographic for it, right?
There are a few tools that we use to do this. Tableau is a software that you can download and use it. It has a graphical user interface and you can test it out. Matplotlib is a Python library, and so is Plotly. Here are a few results from Matplotlib. It allows you to draw different types of plots, and it's generally the easiest to use graphing library in Python. This is Plotly. In my opinion, Plotly looks a little better, and you can use either of the two. For simple applications, you can use Matplotlib, and if you want something that's more detailed, you may use Plotly. Here are the different types of plots that one can have.
So one of the most common one that you'll see around is the simple line plot, right? And here's a brief code for it in Python. What you'll notice is that Python is something that a majority of the developers are using these days for artificial intelligence, because it provides a lot of advantages in terms of, you know, being open source and having a lot of libraries that kind of support the work that we do. So coming back here, we have a simple line plot, really easy to read, really easy to follow. Another one that we have, another way to kind of showcase your data is through subplots, right? Have two plots in the same window, kind of showcasing different variables. Then you have scatter plots. I'm sure everyone's kind of seen all of this. And then we have histograms.
Histograms can help you represent the distribution of your data. You can have bar charts to represent and draw comparisons in different data fields. You can have pie charts. Now, when you have your data, there are a few things that we do to it. Now, the first operation that we generally get into is called batch normalization or standardization of data. If you have different data fields and they're not on the same scale, well, to normalize them and get them on the same scale, we use this process. In images, it looks something like this. Like, for example, like if you're working with you're training a model that works with images. And you see, like when you click pictures on your phone, some images are just lighter, some images are darker. And you can use that slider to up and down to make it brighter or darker. If in your data set, you have images like that, some images are just brighter, some images are just darker. So it affects the features that the model is going to learn. So you get them on the same scale so that the model can look at the features. When you have your data set, sometimes it's not enough. These models, AI models, whether they're images or any other type of data, they require a lot of data to train. So we use this to create more data. Let's say you have images, you can scale, skew, rotate, bend, and do all of these things to, like from this one image, you can generate so many images. What we do with our data and what our model has to do in the process of training is that it has to recognize and learn the features that are in there. Let's say it has to recognize a horse. So it has to look at enough horses and recognize the features that make a horse and learn from it. So sometimes what we do is we remove the features that we don't need. Like in images, we remove the background, which is many a times unnecessary. Or in speech data, we remove the background noise. And feature extraction is an important process, which for many models, it makes the training process easier and gives better results. We can use something known as generative training. And in generative training, what you do is you use these algorithms, which are called generative adversarial networks. and you use them to generate similar images to your data set. So you can generate fake images, which are almost very similar to your data set, and you can generate n number of them, and you use those images for training your model. Here are some libraries that help you do normalization and the various processes of getting to prepare your data set. And those are NumPy and SciPy. These are both Python libraries. When you get to how to decide which model to use for your problem, you can look at a lot of things. First of all, it depends on what type of data you're working with, and how whether you want it to be efficient. Do you want to use a large model if you have the computational capacity, or you want to use a smaller model? Do you want to use a pre-trained model? Do you want to train your own? All of these things. But there's no protocol for, okay, this is going to be the perfect model for your specific problem. You have to try and test out and tinker and make it better over time. Now we're going to talk of some of the tools and libraries that are used to build the different AI models that we use on a day-to-day basis. And some of them are these. So on the left in the beginning, this is CreateML. So everything that runs on Apple devices, it's running under CreateML, which is Apple's library. This is Microsoft CNTK. A lot of research papers and a lot of research implementations use Microsoft CNTK. I mean, they have its references. Researchers use CNTK. Sonnet is made by, it's kind of like TensorFlow. It's built on top of it. Keras and TensorFlow are one of the most used libraries because it can run on mobile, it can run inside web browsers, and it's generally easy to use. PyTorch has been increasingly, its usage has been increasingly growing. It's an alternative to TensorFlow, and in some cases, it's easier to work with PyTorch. It's less abstract and more direct. Now we should see and get into what are these models that we're talking about and how do they work. We can start with one term which you might have heard recently. It's called deep learning. So these are these deep neural networks that are a part of various models that we interact with on a day-to-day basis. What it means is that there are these models which have a lot of nodes, and they have multiple layers, which is why they're called deep neural networks and why it's called deep learning in the first place. And all of these building blocks inside these models, so the AI models that we saw in the past, the image recognition models and various models, when they are graphed and represented, they look something like this. And these models, each and every single dot within these models, all of these dots are called perceptron. And what they do is they basically add up all the previous inputs of the previous layer, and then they are arranged layer by layer. And there are there can be thousands of these nodes. This perceptron just adds them up and gets them on a single range from 0 to 1, as in when the perceptron is activated or not. It works very similarly to how a brain neuron works. These are the functions, the math behind how it works. We won't get into that. We'll just get into how it works. So this is something known as a convolutional neural network. This type of network is used in all of the image recognition models. So whether you're talking of facial recognition on Facebook, or facial recognition for attendance, or any other application, or in Google Photos, like when you go to Google Photos, it recommends you things. This is the model that's running in the background. So an image is an array. An image is an array, like for example, if it's dark, it's closer to 0. If it's brighter, it's closer to 256. And pixel values are from 0 to 256. And you get them on a scale, you get it from 0 to 1. So it's 0.5, 0.4, 0. And an image is a two-dimensional array of all of these values. When it's in colored image, it has 3 channels, red, green, and blue, which gives it color. Now our model is trained such that when the images pass through it, and we want to, let's say, classify between
Just hold on 1 second, people. We, I think, are having a...
It gives a higher probability. And if it's not dog, it's something else, it gives a low probability. So the values of these nodes, and these nodes, the values in them, they're called weights. And when a model is trained, it looks something like this. So this is a building block of a convolutional neural network. When you multiply this with an image that has a 0, it would give you a higher result. When you multiply this with an image that has a 1, it would give you a high result. Whereas if you put a 0 in it, it would give you a low result. And that's how our models can classify. When we train a model, we pass on thousands of images that have labels attached to them. And when they pass through a model, they affect the values of all of the nodes. And we can represent the values of the nodes like this. And we randomly initialize them. And our goal when we're training is we want to set these values. We want to set these values in a way that when an image passes through them and it has the feature that we're looking for, the model should give a higher score. And so likewise, we set it so that it produces higher result. And that is known as the training graph. And that is what we do when we're training a model. We're adjusting all of these weights and parameters so that when our data is passed through the model, it gives the result that we're looking for. And this is all the algorithm. This is the algorithm that runs in the background. We'll get into this later in our sessions later on.
All right. So we went over a lot of interesting stuff just now. So let's relate it a little bit with what we saw in session 1 about data and algorithms, right? So what you learned about right now is Perceptron, which is like the basic building block. And then we went into CNN. And now we are kind of coming back to a machine learning overview. Now, machine learning dealing with data has different categories of algorithms that we can utilize for our data. This is supervised learning, unsupervised, neural networks, and deep learning, which is what we kind of just went over, and then reinforcement learning. So let's kind of see what all we can talk about. As Aryan mentioned earlier, it's a subfield of artificial intelligence because it is and it deals with the construction and study of systems that learn from data. So what we need is data, right? Without data, none of this would actually properly work. So let's talk more about, the terminology that we use while we talk about machine learning. So you probably heard the term features and samples and feature extraction and training and evolution set. So these are a few of the things that we utilize that when we're talking about ML. The most important thing, I guess, is features and dimensions that we talk about. When we have a data set, the different attributes of it, do they define the dimensions or something else? Aryan, what do you think?
Pardon?
When we talk about dimensions of a data, we end up using this term dimensions quite a bit, right? So
yeah.
When we talk about dimensions, it's referring to all the attributes that a particular data set has.
Yeah, a data set can have a lot of different types of features in it, and all of them, we are to look at the features which are relevant to us when trying to solve the problem, and that's our goal.
Absolutely. So we'll get to discussing about dimensionality in a little bit, but let's talk about training and testing. So when you have a data set, training is a word that we just talked about a little while ago, right? Training is, in other words, basically you're making the algorithm learn. It has to learn from somewhere, and data, the training data set is what helps it learn. Now, the practical usage of a particular application is what allows us to kind of test out to see how well our algorithm is performing, and that is the practical usage that comes with the data.
So what you do is, when you have a data set, to train a model with it, you divide it into 2 parts. So first of all, we have our training set. We use our training set to train a model. That is to adjust all the weights, to adjust all the nodes that we saw earlier. And to see how our model is performing, to see how we are adjusting to get to the bottom of the graph and how we are adjusting to optimize a model, we divided it into two sets, and we use the testing set to evaluate the model. Generally, we use an 80-20 split, which means 80% of the data we're going to use for training and 20% of the data we're going to use for testing. Our training set is used for training the model, and our testing set is used for evaluating the performance of training.
That sounds fair. However, we have to make sure while we're doing that, that we are not using the training data as the testing data, right? The same data set should not be used for both cases. It's always either a 70-30, an equitable division of the data for training and testing. So this is a general workflow that we utilize for our algorithms, and we'll get into more details about this as we progress on with our sessions in the upcoming weeks, right? So when we talk about machine learning, there are 4 distinct categories that we talk about: supervised, unsupervised, semi-supervised, and reinforcement. So let's go over them briefly and try to understand what they are. So supervised learning, if I were to talk about in technical terms, there are classes of data that are known, and based on that, our model learns from it. If I were to take it down a notch and talk about it in general terms, it's basically like learning through a teacher, right? A guided learning. Basically, you have supervision on what you are following through. The algorithm knows a little bit about the data set and is able to classify and predict certain things, whatever our goals are with the algorithm. When we get to unsupervised learning, however, is learning like you have no information and you have no idea what the training and data sets, what the data sets are doing. It's kind of like, you know, how basically caveman explored the world, right? They had no idea of what was happening. They tried, and if it worked, if it properly grouped together, it worked well. So unsupervised learning is a little bit like that.
When you have a labeled data set, it's supervised learning. When you know, let's say you have images of cats, and you have all of the images labeled. Okay, this is a cat, this is not a cat, cat, not cat, or dog, or any other example. When the data set is labeled, that's supervised learning. And when it's not labeled and you're proceeding with uncertainty, that's unsupervised learning. And we can have a mix of both the two, and that's called semi-supervised learning, which means that part of the problem we understand, we have labels for, and the parts that we don't understand, we approach in an unsupervised manner. And then we used a hybrid conglomerate of both the two.
All right. So now the next one that we have is reinforcement learning. Now, reinforcement learning is a little bit more interesting in comparison and a little bit different in comparison to supervised, unsupervised, and semi-supervised. So we have an actor or an agent that basically learns its environment based on or modifies its behavior based on a penalty reward system. So for an action, they receive either a penalty or a reward based on which they modify their course of action or the policy development. So what the different steps for reinforcement that we take, the agent observes an input state, and then the action is kind of determined by the decision-making policy that we were talking about. So which is ultimately dependent on a penalty or a reward-based system.
Imagine a video game and a video game character, let's say GTA. How video game AI is trained is they have a lot of different examples. Now, with the video game AI, if it performs correctly, let's say an opponent in a game, if it performs correctly, which means that if it hits another opponent, it is given a reward. And when it dies, it's given a penalty. When it loses health, it's given a penalty. And it runs multiple simulations of this. And the ones that perform well, the system derives a policy, and then once we get to a satisfactory result, that is the policy that we derive onto. So each and every action is given either a reward or a penalty, and over time with different simulations, the actor derives a policy, And that's our reinforcementally learned model.
So basically, reinforcement learning is kind of similar to what we do, right?
Yeah.
Right. We learn based on a penalty or a reward, however significant that may be. That's basically how we move forward.
We do. Let's further get into some machine learning techniques. Here are the terms that we looked at already.
So classification, clustering, and regression. Now, even though we've kind of looked at them before, let's just go into them a little bit, right? So classifying something into a predefined category, that is classification. We do it every day, right? But teaching the algorithm to do that, or to train it to do that, is something that falls in the machine learning analysis that we are working on. So now classification is a supervised learning. It's based on, like Aryan said, it's talking about label data. So classification is a supervised learning based thing. A similar thing that we have is called clustering, which is now unsupervised. The thing with clustering is that it's going to group the given data set into certain clusters, or smaller groups. Now there are different methods of doing clustering. The most popular ones that we have are k-means clustering and hierarchical clustering. Let's kind of understand briefly what they are without jumping into the mathematics of it right now. So let's look at this. Let's talk about k-means clustering first. So what we have on the left is the original unclustered data, all blue dots, right? And then on the right, the image has 3 clusters. So 3 smaller groups that have been created based on certain parameters. Now K here, why is it called k-means? Because we are developing K number of clusters based on the mean of the data sets, right? So we ended up, in this case, based on our analysis, we ended up with 3 distinct clusters. All right, the next one that we have is the hierarchical clustering. How is that different from k-means? Now, hierarchical clustering, it allows you to build a gradation of the clusters, right? So this can be done in 2 ways. One is the bottom-up approach. What the bottom-up approach does is that we have n number of clusters, and where each data set, each data point starts out in its own cluster. Then based on our algorithm, it kind of moves up, and we keep on merging these clusters to form distinct clusters, the minimal number of clusters that allows us to put together data points that are similar in nature. This is the agglomerative approach to hierarchical clustering. The next one that we have is the opposite of this. It's the divisive one, right? As the name says, it divides. It's a top-down approach, so it divides into clusters. We start with one big cluster, and then we move on into based on our algorithm and our observations, we move on into smaller clusters. Ultimately, our goal is to develop a clustering method that allows our data set to be partitioned into groups with features that are alike, specifically focused on what we are aiming for. So moving into regression. Now, regression is a term that I think everybody has heard of. Regression analysis basically is a statistical process. What we are doing is we have n number of variables, and we're trying to develop a relationship between these variables. How is this useful? It becomes useful in a lot of cases for us. We sometimes have a large structure of data, and we kind of want to figure out how one particular parameter is going to impact the others, and how that's overall going to affect a certain situation. So basically what we are doing with regression is analyzing the impact of variables and their interrelationships to kind of predict what the output value is going to be. Again, here we do have training and testing data set. The most common one that people end up using is the logistic regression models that are applied on a majority of the data sets that we are analyzing. So let's talk about classification versus regression, right? So regression we are talking about as prediction. We are talking about interrelationships and how we are using those interrelationships to predict an output value for our data set. Classification, however, is we are grouping the outputs into a certain class. So let's talk about dimensionality. This is something that we started talking about earlier, but now let's talk about dimensionality. Just as a quick reminder, dimensionality refers to the attributes that are present in the data set.
Sometimes you can have a lot of things in your data set that you don't need. Let's say, for example, you want to train a facial recognition model and you have a lot of things in your data set, a lot of features that you don't need, but which is something that your model can get confused with. So that is additional dimensionality. You have to reduce the dimensionality of your model. I mean, more data is good, but confusing data is bad. Which is why sometimes we say less is more. When you have a data set which has a lot of features which are not of relevance and you have dimensions and dimensions of data, let's say you want to train a model which takes in a patient's medical history and predicts a medical outcome. You don't want to have in all the data as in what they do for cosmetics or how their social media is looking or anything else. Those are dimensions of data which are not relevant to the problem. And likewise, we need more data, but we don't want data that's unnecessary and in other dimensions. So what we do is we sometimes tend to reduce the dimensionality of the data. But we have to be really careful when we do that because our data at the end has to represent the problem. Now, if you look at this image, it hints something, but practically applied it was not that. Now, many times when we're working with a data set, we may derive at points and our model may derive something, a cause and effect relationship between something which doesn't exist. So we have to be really careful with how we are representing our data. Are we removing too much, or are we adding too much, or just the right amount of information that's needed? And that's how we optimize the data set. Those are the features that we choose to include in it. If we talk of dimensionality, this is more mathematical. You can represent shapes in different ways, and you can have, but largely, what this means is you have to have as much data as possible, but you don't have to have the data that's unnecessary so that your model gets confused.
So basically what we're saying is that before we start our analysis, we're back to that point where we kind of have to have a really good understanding of our data before we jump into the analysis of it?
Yeah, which is why we use different visualization techniques, and we collaborate with field experts, the processes that we talked about earlier.
Exactly. So understanding your data so that we don't end up in situations like this one in comparison to this one, we should really have an understanding of what our data is trying to tell us. And that is why data visualization and other techniques that we have talked about in this presentation kind of become really important. So dimensionality is dangerous, right? So I don't think I'm not sure dimensionality would be dangerous. It's just wise dimensionality is what we have to focus on, right?
Yeah, I mean, when we set out to solve a problem, there are a few features in which the problem's outcome depend upon. And those are the dimensions that we need. And we need all of the data from those dimensions so that our model can learn all the relevant features. And we need to include all of them. Let's say if part of the image is cutting out, let's say, and it has features, we need that data. We need all of those dimensions. For sure. We just don't need the data that may be irrelevant or may confuse the model, and we try to feed it in, which is why we talked of feature extraction earlier.
Yes, so details of feature extraction is something that we're going to cover in few of our next sessions, kind of how to deal with data and do all of these techniques basically. So let's talk about
There are a few use cases again. So when you I'm sure you've seen Google News or any of the news results that even the Google homepage has. What it does is it takes an article and it does something known as abstractive summarization. There are different ways of summarize a text using artificial intelligence. The latest ones are abstractive summarization. So previously we used something known as subtractive summarization, which is we just remove different parts of the sections and we reuse the sections. But now the newer models are using something known as abstractive summarization, wherein they take an article, they understand the meaning, they contextually understand it, and then they rewrite the sentences to make it smaller. And such models are being used by Google everywhere, in their search, in their news, everywhere. So Google now understands all the articles that you put over there. Even when it reads your articles for search engine optimization, it semantically understands what content is there in your article, and then it filters the search results accordingly. Likewise, on Yelp and all of the reviewing platforms, natural language models are used to analyze how good a product is performing and generate a reading. That's sentiment analysis. We can do something known as anomaly detection. There are models that perform very well in the task of anomaly detection. Let's say you have a regular list of transactions and there's a transaction which is out of the order. That's an anomaly. And this particular application of artificial intelligence is used by banks and credit card providers for fraud detection. Sentiment analysis is something we talked about. Decision making, AI can help us give trends. When we talk of classification and prediction, it can give us trends and it can give us insights into different fields and different types of data, and then that can help us make decisions. When it comes to decision making, there's also another application. I've seen reinforcement learning models, and they're basically trading bots. So they look at multiple different stocks or even cryptocurrencies, and they maintain a portfolio and they make a decision on when to invest and when to take money out. Now, the advantage of performing such a task with machine learning is that it can look at the data of the last 10 years, 20 years, how many years, and it can remember all the data points, because that's it's like human versus calculator. So when we have such advanced algorithms which can look at all of the data points, and it can do a time series analysis, and it can use reinforcement learning and make a decision on when to purchase or to sell in the finance sector, we have decision-making algorithms. And these algorithms can be used in other domains as well. Sentiment analysis is being used everywhere in all of the social media algorithms. And even our own project, the autonomous review system, is an excellent example of the state of the art, the very best in sentiment analysis. Speech models and language models are used in all of the virtual assistants that we interact with every day. And likewise, their adoption has been increasingly growing. They're getting better. Nowadays, the speech to text models are getting so good that you can use them to narrate anything for you. And basically, that's how I read, by the way. So I use Apple's narration service, and I have a PDF of a book, and it just reads it out to me. And it uses the GPU now. It's GPU accelerated, and it generates that. It doesn't just copy paste the different syllables and create speech to text. Now it's generative. The models have gotten a long way, and it's going to be such a trend. And these models are going to get more and more efficient. So all of these models soon you're going to be able to run on your mobile phone. Face detection and all of the image models are being used by Facebook and all the social media companies that do all the face tagging and all of that. And image recognition models are used in Google Photos and all of your, when you click a picture on your smartphone, it uses the It says AI, and it uses these models to understand the scene. It recognizes the subjects over there. It understands the scene and applies the best filter and the best adjustments. So what it does is it classifies whether there are people in the scene, and it brightens up people. If it recognizes that there's the sun or the sky, it turns on the HDR mode, and it also applies filters. If it sees something green, it applies a specific filter, and it shows you different modes. And that's how image recognition models are being used on it. We are already surrounded by AI in various different things we do every day. Now, talking more of the natural language applications, NLP, which is a subset of machine learning, we get into some of the tasks that are there in the process of creation of natural language models. This is what we begin with. To understand any piece of text, what we do is we do named entity recognition. You see this paragraph. Now it can classify what is a noun, what is a time, what is a person, location, whether it's a proper noun, what is the subject, what is the task. And a very good example of where this is applied is Siri or Google Assistant or Alexa. When you tell them to do something, they contextually understand who's, which app does it refer to, what task is it, and who does it want you to call, which particular word in the whole speech to text recognized output is the subject, and which is the contact that you're talking about, what is the name of the app. So it does named entity recognition, and then it performs tasks accordingly. So named entity recognition is one of the tasks there in machine learning in the subset of natural language processing. In a data set, sometimes there can be similar or duplicate images. These are helpful. We can generate more such images by doing data augmentation. And you can find similar images and you can use this LIRE module to get similar images and grow your data set. Next up, you have something known as recommendation engines. Now, you all might have seen labels like this when you go shopping on Amazon. It recommends you products. It recommends you things you might buy based on your purchasing history, based on the things you've looked at, based on the categories you've browsed. So it understands you. There are these recommendation engines in the background which contextually understand each and every single action which you perform, and then they predict your future actions based on those actions. Recommendation engines are a part of all social media networks, all of the content browsing networks, even YouTube and everything, and it recommends you content that you would like to watch.
And if we talk about it, these recommendation systems are fairly accurate, right? I mean, if you're watching a video on YouTube, say, if nothing else on solar energy, the next 3 days, those are the videos that you're going to see. So these recommendation systems are that we're already using without realizing in some cases are highly accurate.
Yeah, YouTube's recommendation engine is actually quite powerful. And YouTube has this tagging mechanism. When creators on YouTube upload a video, they have to give tags to a video. So all of the elements that are in the video, they have to submit tags for them. Something which I read about and what YouTube is exploring is that they are using AI to analyze what's in the videos. They already do, if you see on YouTube, they do live captions, which means you can turn on auto-generated captions, which means that it looks at everything that's said in the video and it uses it for search and it uses it for recommending content for you. And likewise, it has many language and computer vision models that help understand the videos, and then the recommendation engine that YouTube has, it understands your likings, your preferences, your interests, whatever you'd like to get into, and then it mixes all of that and it predicts what are you most likely to watch next, and that's how it fills your explore feed. Yeah.
And the inverse of what you're talking about is also true, right? They're also using the same AI to kind of detect any videos that are unsafe or that breach their policies, basically, and kind of restrict them from viewership. Or, you know, a lot of people set up age bars, like, you know, under 18 or certain that their kids cannot view it. And I think all of this is being done by their AI.
Yeah, very much. And these recommendation engines are everywhere now. Even content-based websites, you know, they're using this to, whenever you go to a website, they're storing cookies and they're creating a profile, they're looking at what you're looking at, and they're crossed, even in advertisements, if you see. Google advertisements, a lot of websites use Google advertisements. And so if you set up Google ads on your website, and basically it just knows you and wherever you've been and the things you're interested in, and you would see those advertisements everywhere.
That's
on
true.
website. Yeah,
It's very true.
it's the same it's a very similar recommendation engine in the background.
All right. So with these, something else that we want to talk about is here.
In this presentation, we don't want to dive too much into the math behind machine learning, which is something that we'd get into in our future sessions. So all the developers who are looking to start their career or grow their career in machine learning, feel free to attend all our sessions in the future, and we'd love to host you.
Yeah, so the important part to understand is our session today is focused on getting, you know, the overview across to you, kind of getting the basic concepts in. But we have to realize that, you know, with all of this, mathematics is important, and it does basically it is the backbone behind it. And we do have to learn it eventually, but we're not going to compress it into a short session. We're going to kind of spend time on it, learn it, develop it, and then implement it.
For non-developers and people just seeking to make use of the technology, this technology is going to be around you in every single process, in every single workflow, almost in all types of jobs and different tasks that you perform. So and having an understanding of these models, you know, without, even if you don't know the technicality behind them, it's important so that you can make use of them. You understand what they are, and then you can make use of them to your advantage, and you don't, you stay at the forefront of the advantage the technology brings, and you can make use of it.
That's very true. That's very true.
Like we talked of natural language processing, NLP. Natural language is, we refer to the human language that we're talking of, like English or any other language. Natural language processing is the subfield of machine learning, which understands, generates, performs tasks on, and classifies, segments human language. And it's called natural language processing.
All right, so natural language processing is being used pretty much in a lot of applications, right? My phone uses it. I think my laptop uses it as well, right? So we're already surrounded by natural language processing tools here. So, but why do we want to do that? Language is something, you know, there's a lot of advantages to using language processing. Human language is a beautiful thing, right? It's designed in such a way that we have to, the speaker has to convey something in a way that everybody can understand. So when we talk about human language, it's, you know, very symbolic. It can be, you know, so that we can kind of generate more reliability with it. However, without the tone inflection and everything, it's difficult to kind of understand what the actual meaning is, right? If I was to go into and just talk like this, it would be very difficult to understand what my true meaning is. Therefore, natural language processing in itself offers a lot of challenges for AI models. So when we're talking about natural language processing analysis, we're talking about the syntax. The syntax, is a general term that I guess is used both in computer science as well as in English. In English, it specifically refers to the grammatical order of the words and parts of the sentence that you use. So when we talk about the syntax, it analyzes what part of the given text is correct grammatically. Then it talks about, then it evaluates what is the meaning of the given text, right? This is something that we have to kind of understand. And this falls in the semantics part of it. And then what is the purpose of the text, which is the pragmatics. So when we talk about the process of natural language processing, we get two distinct parts of it, right? We get the understanding and the generation.
And the working together of all of these aspects within them can help us create natural language models that help us do tasks in the real world, like Siri, like Google Assistant, or any other task. Natural language processing within it has natural language understanding and natural language generation. Natural language understanding is the understanding and the making sense of what's said and what a specific piece of text means. It is about breaking down the language and then getting it down to simple to understand syllables for the machine so that the machine can perform tasks on it. Natural language generation, the next thing is, nowadays there are these models. So I got the beta access for GPT-3, which is the world's largest language model. And it's made by OpenAI, which is headed by Elon Musk. And this particular model took $6.5 million to train. So natural language generation, when we use the model for that, it can help us generate pieces of text. It can help you write emails. It can help you with your homework. It can, from a range of ideas, generate a well-formatted idea, generate a well-formatted paragraph, generate a well-formatted article, generate a well-formatted piece of homework. And these models, these larger language-based models that are coming out right now, these are transformers. And these models are now just huge. They have billions of parameters. OpenAI's GPT-3 at the moment is the world's highest performing model in the domain. And there are a lot of applications which that particular model has. Like, for example, someone made a blog with it, as in a blog in which all the articles were written by GPT-3, and it was undetectable it was not detectable for 2 weeks. As in, AI was writing all the blogs and it was submitting them on different platforms, and its ranking rose up. It only became visible when it was the top ranker in some categories, and then people could see a few repetitiveness and a few patterns. They were like, okay, this could have been written by GPT-3, and they were correct. So these language models nowadays are really good, and as their practical usability increases, as we tackle the few challenges, and we are the people who are tackling the challenges to get it out, to build technologies, to build apps, to build real world applicable systems that are applied in different tasks and different processes in the world, it's going to be out there very soon. So all the tasks that you find tedious when it comes to language, like for example, all the communication that there is, these language models can help you understand, break down, and generate and compose your own ideas and help you with n number of tasks. Students can use it for their homework, for the correction and improvement of, even if you talk of extensions like Grammarly, they use natural language models. But the models that are coming out right now and are going to be a part in the different, and are going to be embedded in different apps in the future, I predict in the next 5 years, they're going to be much more powerful than that, much more powerful than that.
That sounds pretty great, actually. So when we're talking about natural language processing, We're talking about understanding understanding a particular sentence or a paragraph, right? We're trying to understand the meaning behind it.
The typical natural language models that we interact with are chatbots. Here are some examples that we have seen already. We have Siri, Alexa, Google Assistant. Microsoft has their Cortana. They have two. They had one named Tay, and Facebook has its chatbots. You can create Facebook Messenger chatbots, and likewise, there are different models, and these models are, you can code your own chatbot too, by the way. It's not that complex. It's just, there are different models that you can use, and you can stitch them together to make your own, and then you feed it your own data and you have your own.
That sounds like something we should kind of talk about, So let's also talk about the useful ML libraries that that you can get started with. For computer vision, we have OpenCV and Python imaging library. Now, computer vision is something that we are already utilizing, right? In our photography apps, as Aryan mentioned, something that is detecting our faces in Facebook images and everything. This is something that we are already utilizing. When you're operating in Python, you can kind of utilize these libraries for design.
Python is the most used language for a lot of machine learning and artificial intelligence operations, simply because it's a very powerful general purpose language. It is versatile. It can run on various devices. It's very abstract, as in it's very English-like. I mean, you don't have to write a lot of verbose. You don't have to write a lot of machine level stuff. So it's easy to get started with, so that you can get to the paths which make sense and actually solve problems. And I think that's how programming languages should be. There are obviously some downsides to it, but largely right now in the machine learning and AI space, we use majorly Python. When we obviously talk of deploying it, that's another story. But in the development process, in the creation of models, Python rules right now. When we talk of computer vision, these are some of the libraries that we use. So we have OpenCV. OpenCV is used for a lot of subtasks. Like, for example, like when we made a facial microexpression recognition model, we were to cut out faces. So we used OpenCV for that. And when you talk of Python imaging library, it's referred to as Pillow. It can help you draw boxes, do a lot of operations on your images. And when we are building models, I mean, in 2021, even earlier, I think for some time, we would be using both the two. When we talk of natural language, we have Python's NLTK, Natural Language Toolkit, and it helps you do tasks such as named entity recognition, which was the breaking down of the sentences into different parts. And we have Spacey and Jensen. And using these, we can create a vector representation of words. Like, for example, how these language models work you have words represented on a vector. Like, for example, you have, king, queen, male, female. If we have these four words, so king and queen would be closer, and queen and female would be closer, king and male would be closer, because they have similar properties. So they're arranged that way in a vector map. And these language models then refer to the vector map for the different language operations. And Jensen can help you create such vector maps. It can help you vectorize things. And likewise, there are other libraries that help you do all of the things that are the building blocks of natural language models. You might have heard the term big data. Let's talk a bit about it and what it is, and why is it called big data? What are the frameworks that we use, and what's the difference and what's the distinction? Why is it linked with AI, and just questions around the term big data. Now, big data is the idea that a data set can be so large that it cannot fit on a single system or on a singular database. So then we distribute this data set over a cluster, over multiple computers, over multiple servers, even in our local systems. And with the influx of all of the data collection, I mean, data is the part that unlocks value. It is the fact that Netflix collects the data from you, how much you're watching something, what you're browsing, and all of that. It is the fact that it is collecting all of the data, which is why it can recommend you all of that. So data is important. Now, to build bigger models, I think in the future, storage isn't going to be a problem, but data sets can get huge. The data collected can get very large. And to do that, we distribute them over clusters. And then when we do that, we use models to drive sense out of it, make sense out of that data, derive intelligence and insight from the data, and so that we can make models from it. When Netflix collects all of your data, it looks at all of the patterns, the patterns within different categories, different sections of the Netflix library, and what you browse, the categories you go through, the types of movies you watch, how much you watch them, and everything. It stores all of that, and with it analyze the trends and patterns, and then predicts what are you going to watch next, and it pops up and populates your Explore feed likewise. When we built the models, we are to deploy them so that end users, we are the users for all of the, like for example, Google Photos or the camera app in our phones. How do we deploy them? Various libraries allow you to run the models on the web. Like for example, TensorFlow is big on that. And it also allows you to run on mobile devices. And there's also this thing called Onyx. If you have your model in TensorFlow or PyTorch or MXNet or something else, you can convert it to something known as, you can use Onyx and you convert it to something known as .onyx. It's a type of file that it creates. And then you can run this .onyx file using Onyx onto your browser. And then you can use it to run it anywhere. You can run it on mobile. TensorFlow and PyTorch allow you to run on native iOS and Android. This is what happens when you run your model locally and when you infer it on your device and users are getting access. What happens is sometimes models are too large for any mobile device to run that, which is why we get to the concept of cloud computing. So Facebook's recommendation engine is probably so large that you can't store it on your device. OpenAI's GPT-3 is so large that it can't be stored on a mobile phone. It can't be run there. So what we do is we host the model on the cloud for once, and all of the users can access it. The different devices can send their data for the model to run on, and then the trained model then is run on all the data that's sent by the users, and it returns the data back to them. So most of the models in the large-scale application, they're stored on the cloud. There are different cloud hosting platforms. The biggest ones right now are Amazon's AWS, Google's cloud platform, Microsoft's Azure. There are also others. And these cloud hosting platforms, they work at different levels. There's infrastructure as a service, which means you just get the server and then you can do whatever with it, which is basically you renting out a remote piece of hardware. You can have platform as a service, which means that they manage the hardware, but you run your app and you manage the backend, and this is basically how you host your app on Google Cloud Platform or AWS, their platform as a service. And then the end product, which we host onto them, is SaaS, which is a software as a service. When you host your model online, let's say your model detects something and is useful for a particular industry, like we built the document intelligence module earlier. It's usable for a lot of industries. We had great interest from Mashreq Bank in Dubai and so on. So that is called software as a service, wherein your model runs, users send data to your model, and it infers that the model is run, and then that value that is extracted from that, it can be monetized too, and it is hosted on the cloud, and you can have different instances allotted to your users, and they can have like a monthly model, and then you do the math. This is for end users and so on. You have different types in which you can fit where you can host your application on the cloud. When we host our application on the cloud, we nowadays use containerization, and we use Docker for that. Now, these models, they can be large. They can be so large that they need to be spread across a cluster of computers. Like, for example, our facial micro-expression recognition model was trained on a data set of 65,000 images, and the model itself was large. So what we did was we containerized the model with Docker, and we sent it up to Google Cloud. The reason for sending it up to the cloud is the models are large to be run on mobile devices. Also, users are hesitant to give space on their local device. When mobile apps were introduced, people were downloading different apps. Nowadays, our usage is basically limited to a few apps that we use. I think it's the latest statistics are 6 apps, something around there. So people don't want to download apps, and when they do, people don't want to store a 2 GB model on their local device. So we host it on the cloud, and then we manage it accordingly, and we price accordingly. Now, why we talk of Docker is, this is the Docker's website, by the way, is because it offers containerization. So when we're on the cloud and we have a particular piece of hardware designated to us, whether it's dynamically allocated or it's statically allocated, whether it's a cluster of computers that's dynamic and location is also dynamic, or it's just one part on one system that's given to us based on how we choose, we have different ways of running our model on it. Now, our model requires its dependencies. When it's built on Python, it requires, first of all, Python needs to be run on an operating system. And preferably, it's Linux. There are certain models that require other, basically you can host anything on Linux. Some people who are not comfortable with that, they may use something else. But Linux is the most lightweight and the best option for having your base OS. Now, on your OS, you use all your libraries that your model is going to use. If your model is going to use OpenCV and NumPy and all of the things that you're going to need, maybe you require some data to be referred to in your whole AI model. So you store it over there, and you have all your modules, libraries, and you compile it, you put your model there. When you deploy it over there, you try to make it as efficient as possible. And why Docker is because it gives us the ability to containerize. And the difference between that is when you have virtual machines, when we had traditional hosting in the earlier days, we didn't have all of this. We didn't have dynamic allocation, and we had to. So there was one operating system, and it had a hypervisor, which is basically an allocator. It allocates, 100 gigs of memory to one instance, 6 gigs of RAM to it, and 4 cores of processing power. And then you had virtual machines dedicated to you. And those virtual machines then again would have their own operating system. Let's say you were running Linux on top of it again, and then you would have your modules, all your libraries, and then your different apps. And then you can have multiple models hosted this way. So with previous type of hosting services, we were replicating the OS part too many times. With containerization and Docker, we have one host OS and Docker runs on it, and our app runs as a Docker container. So we don't have to emulate the operating system at multiple instances. With one operating system, we can have multiple containers running on the same. And with this, we unlock the ability to dynamically change servers. Like, for example, if you're building a model, let's say Google's model for Google Photos, now it has to be hosted everywhere, and its allocation has to be, let's say, more people are using it in India. So it has its servers everywhere, and it can dynamically shift to different locations. It can allocate more computers, as in when more people are suddenly starting to use it. Because of this, it can allocate more resources to it. It can allocate more clusters, more computers for the service of the users that have entered. And this is the advantage that the new type of cloud brings us. Basically, any type of app you put it over there, it can handle anywhere from 1 user to like 1 million users. Of course, when you can pay for it. But they are expensive nowadays. They are expensive, but I predict they'd be more cost effective. Now, Kubernetes is the thing that helps you scale and manage when you're using Docker containers, and Google Cloud Platform, as well as AWS and the other competitors, Microsoft Azure included, they all support these features. So the difference between previous type of hosting versus the cloud now is this, where you had different static virtual machines allocated to your service, and they couldn't change. Let's say if you were to change, if you suddenly needed more RAM, let's say you had 6 gigs of RAM, now you need 10 because you have more users, you have to shut down the VM many a times. You have to, that particular machine didn't have as many resources. You have to switch to some others. You have to turn it off and then change the allocation parameters and then restart it. So it wasn't practical many a time. So which is why many companies, they maintained their own servers. And when they had a change in the number of users which were using their apps, it was a tedious process to manage all of that, which is why hosting was a big thing. But nowadays, when new developers when we build a model, we use containers and we host it on the cloud. So on the cloud, it's dynamic. These large hosting services, they have their servers in multiple locations, and your app is basically just floating anywhere and can, based on where users are using it, you can configure it can dynamically scale whenever you need it to. You have various different applications for which you can use the cloud for. You can host all of your machine learning models over there. And this is an example of Google Cloud now. This is how it looks. This is one of our projects deployed over there. And when you make your model, like with all the processes we shown earlier, we'll get into the coding part sometime later in our future sessions. You use the cloud and your model scales accordingly. You can also use the cloud for hosting your regular apps, like web apps or something else. But artificial intelligence with the cloud basically makes it limitless, which means that no matter how many users are there, it would always be responsive, and it would always be fast, and it would always be at your service. Also, there's no limit fundamentally. I mean, there's no infinity there to it, but still there's a big buffer. You can have as much data collected as you want, and with that data, you can deploy intelligence, you can deploy different AI models, and those AI models can look at those pieces of data, and that can be turned into services and models which are adding value to people, solving tasks for them. Different models that can be run without, being too computationally expensive on mobile devices. And mobile devices too, by the way, are getting a lot better at handling these tasks. What this means is smaller models can be run on mobile devices, and you don't need the cloud for them. And for larger models, you can have even larger models be run on mobile devices, because even when you're running the model on your mobile devices, you can have the pre-processing and the representation of the results of those models done and carried out on the mobile device itself. And all of these things are offered to you by cloud hosting services, and this is sort of how it is. It's not sponsored by cloud hosting services, just that Cloud hosting services with artificial intelligence is in the present day, it makes it a lot easier for anyone to get started with AI, build their models, and have it be done in a way that it's scalable, deployable, and of utility to a large number of users. This is what gives your app like a way to reach your users. With this, we're done with all the theoretical part of the presentation. It's a lot of content. It's a lot of content to cover. It's a lot of topics we've touched upon today, and we'd get into the details of these topics later on. But now we want to let's have a question and answer session. Let's explore ideas. Let's make it interactive. Let's see, we want it to be such that you open up to the different ideas and possibilities with artificial intelligence. Where do you see artificial intelligence applied? And then give us, different, questions or ideas or, feedback on how you think it is and everything.
Yeah, I think that sounds great. So let's start a Q&A session. So if any of the participants would like to either ask a question or start a topic of discussion, or just, kind of get a more general idea of something that we talked about, just either press the raise your hand or drop a message in the chat box, and we will go with that.
Yeah, we'll answer all the questions, queries, statements, and different ideas. Let's explore ideas. Let's explore, the fields that you're interested in. Let's talk of how AI can apply to your field. How you can make use of AI. What types of models do you think are going to be there? And let's brainstorm and think of ideas. Let's give us different fields. Let's talk about them. Let's see and discuss how AI is going to make its impact over there, how it's going to help, what value it's going to add, and everything in between.
Well, I have one. Let's get started with a topic that we didn't include in our presentation while our participants are coming up with their questions. How about food technology is something that we talk about? How artificial intelligence can help with, food growth, maybe food delivery. That's something that we're already seeing in terms of food delivery. We've all used either Uber Eats or Swiggy at some point.
There's supply chain automation. I mean, largely it can be termed as that. AI can help optimize the routes of the different transportation routes, and that applies to the procurement of food, as in when it flies from or gets from the farms to your dining table. The transportation in the middle, that also includes all the food delivery apps. The food delivery apps, by the way, they use artificial intelligence already. I mean, they use it for the simplification of routes. They use it to optimize time. They use it for bike allocation. We actually worked with Deliver, which is the largest bike procurement startup that helps these food delivery giants in Dubai. And we made a model that helps optimize their efficiency. So it would look at all of the condition of the bikes, the performance of the riders, the service schedules, predictive maintenance, the routes, getting them to the shortest routes based on how previous drivers have delivered, and so on. AI is applied everywhere. So supply chain is big. Also, there are a lot of applications. Computer vision applies to that. You can have, there are these apps out there that you can download right now. Like you can click a picture of a plant or a crop, and it would tell you what disease the crop has if it has diseases.
Absolutely.
And so on. All of the processes can be automated. Let's say a drone has a camera and a humidity sensor, and it flies around crops. And then it detects how the crops are performing day and night, and it, over time it repeats that. And then it can turn on the sprinklers by itself, or there could be a robot that looks at the soil, and then you can have the chemical composition sensor, you have the gas sensor, so you can sense when it's the right time to put in fertilizers and other things. So a lot of processes within that can be automated, and so can the supply chain, and that applies to other fields as well. Food as well as all of the business processes that are out there. I can't imagine any single field which wouldn't have AI be a part of it. Even if you talk of students, AI is going to change a lot of things for all of students. We are all students, but it's going to change how we learn theoretically, as in it's going to, when we have these models which can do all the repetitive things for us, we wouldn't be made to learn the repetitive things. So yeah, there's that.
Yeah. So coming back to food technology a little bit, I think that's something that is already in practice in some cases, because not just the delivery aspect, but what you were talking about, growing the crops and everything, in terms of determining when the fertilizer is to be put in. And then we also should consider the fact that agriculture requires, traditionally it has always required land, right? With growing population and everything, that is becoming challenging. So with the new technologies that we're introducing in terms of vertical farming and greenhouses and everything, then artificial intelligence plays an important role when we're talking about it, because that's how artificial intelligence can control the nature of I'm sorry, not the nature, but the environment in which a particular crop is growing when we're talking about greenhouses and vertical farming.
Very much so. It can have a drastic increase in, and it can have a drastic increase in the efficiency at which we grow crops, and also the quality, because when it's automated, you can have the quality look at by the machines 24/7, every hour or something like that. And it can help farmers do much better, and it can give them analytics. It can give them, we can program, the AI model can learn the best practices, and it can learn from how the crops are growing, and it can dynamically change its strategy. A lot of things are possible. That's true.
And I agree with what you're saying about AI being applied to almost all aspects and sectors that we work in. I mean, essentially, artificial intelligence can improve all the workings of everything.
Yeah, very much so. And this is one idea. On-screen tasks are going to be automated by AI much faster than off-screen tasks. Obviously, off-screen tasks are going to be automated as well, but on-screen tasks, they would be the first to be automated. So any repetitive desk work or any repetitive task would be aided on and helped by AI, very quickly. Like in the next 2 years, we're going to have such tools that are going to help us do, let's say you've given a repetitive task on your computer, like let's say writing an article, or copying, pasting something, if you're, or typing something out or something like that. Those tasks would be just helped with the application of artificial intelligence. So people can do the more meaningful tasks. People are left to do the more meaningful tasks, and the tedious tasks that are carried out by AI. The parts that we call mundane, the parts that we call boring, those parts are going to be addressed very quickly.
I think that'll be exciting,
Yeah.
So we have a question coming in. I'm going to unmute. Yes. I mean, if you're not able to unmute or use the microphone, please just type the question in the chat box. So the question is how AI can be applied in legal issues, or in how it would work in the area of law. That's an interesting question.
It is. I think the applications can be twofold, as in for the victims and the claimants, it can help them make sense of the particular legal clause and break it down into natural language. This is actually one example of GPT-3, the large language model I talked about. And that language model helps users with a lot of things. And in the legal space, for example, it helps them to break down the different clauses of laws. And likewise, it can have people refer to different laws. Let's say when they're reporting a problem, let's say a financial fraud or something, and on a platform, they go over there and they fill in something. The AI model can help them better refer to the exact pieces of law, the statements, the exact verses which are relevant for the case. And
Absolutely.
for lawyers, AI can help them in the drafting process. AI can help them find similar, let's say in the copyright or intellectual property space. AI can help search for similar ideas because we can use these language models, and we can use these language models to find similar terms, and we can look up those similar terms, and then it would help lawyers in their processes. So automation of workflow processes, and then creation of tools that help the end users, like breaking down of law, or helping them better understand what laws are there. Let's say, like you're talking to Siri, you're talking to a virtual assistant, which is like a dedicated law assistant, and you're telling them, okay, this is what happened, and then it tells you these are the laws that exist, so that you can be more aware on what laws are there. Basically, a lot of end user models can be there, and then for lawyers, workflow automation.
So basically, the initial consultation we can kind of do through AI models.
Yeah. And once we've done that, it can be like that intelligence can be programmed into a machine learning model, and then that model can help people for as long as people want to use it. It can have an uptime. It can have a 24/7 uptime, and it can be there to serve people. Also, It can understand, part of the tasks that lawyers do, but simpler. AI can help people with that, like the breaking down of legal language is one. And even, another application, by the way, for lawyers, they have to do a lot of paperwork. So AI can help in the digitization of all of the paperwork and the simplification of tasks. Let's say if, you had to take a task after reading a letter. So AI, you just put it on your desk, and on your desk, there's a camera, and there's an AI model that's connecting your camera and the computer. And the AI model digitizes it and then understands it and boils it down to a few tasks you can just select and tap your screen with. So, there are a lot of things in workflow automation that AI can do.
Yeah, absolutely. So we have another question on how AI will impact marketing.
Yeah. Marketing, I think, first of all, in the process of marketing, there's understanding your customer. So we are the pioneers in that space, where we have the world's highest performing facial micro-expression recognition model. And we made an autonomous review system a while ago, which has 5 different models to understand your customer. Basically, you can use something like that to better understand your customers. And then also another application that's coming up using language models, other than this one, other than the part of understanding your customers, is that when you're creating a copy, what I mean by that is, let's say you're writing an Instagram post, or you're writing a piece to attract your customers, or you're writing a piece for your customers, AI can help you write that text. There are tools that are going to come out using GPT-3, which will help you. If you have a piece of text, it would help give you different suggestions of what could be the headline of this piece of text, piece of copy, or what can be, there are already existing models which tell you how emotionally effective something is. There are AI models trained on large data sets which have seen which pieces of advertisements have performed well, and it can give you a rating, and it can help you generate these pieces. Also, when you have your customer data, AI can help you get intelligence from it, as in it can help you look at patterns, and it can help you basically derive insights from all of the data that you're generating. Even that's for the future, or any process that's digitalized. Even for any process that's not digitalized, we can digitize a feedback book. We've worked on document intelligence, and it's possible. One can digitize a feedback book and then analyze using keywords all the things that the users have said, and then derive what intelligence can the business get from all of the trends that have been analyzed. And it can also be predicted.
That sounds great.
Do you want to talk of any specific application within marketing or any specific use case? Sort of. I hope that answers your question, but any specific use case are you mentioning? I guess, anyways, do we have more questions? Google AdWords AI. Oh, okay. Google AdWords and AI. Google's AdSense already uses all of the tracking data it has for its customers, and it shows them relevant ads. Maybe with all of the customer data you're generating, let's say a feedback book, you can use AI to boil down the keywords, as in if you have a lot of customer data, let's say for marketing, you've understood your customer and you have feedback books, for example, you can use AI to generate the keywords from that, extracted from all the data you have, and then you can use the keywords to better target your customers in Google AdWords. So you can have AI understand your customer, and then with that understanding, you can derive keywords, and specifically for AdWords, you can put those keywords over there. And that's also true for any type of social media marketing. So AI can help you boil down your customer reviews. And like we talked of the vector map and vector representations, AI can find out the common patterns in them, and then based on which vector on the vector map, which words are closer together and which words have the highest frequency, the model can give you a list of the keywords that give you an understanding of your customer, and then you can use those keywords for advertisement and marketing. Why not?
I think that sounds great. Saurabh, I hope that answers your question. And do we have any other questions?
Do you have any more questions?
Any other areas that we would like to explore today? All right. So about this, we work like this. We enjoy discussing artificial intelligence, so we invite everybody to kind of participate in that. So if you feel like you have even a random idea about that you want to discuss, just feel free to drop it in the chat box or just raise your hand and we can discuss.
And also, you can reach out to us anytime through our social medias or on our email or anywhere, And it was great talking to you today, and we would have such sessions in the future too. And if you're a developer and you want to learn how to build these models, and not just AI, even further technologies, the latest and the greatest in web development, app development, and so on. And if you want to partake into the process of development, we have a learn and grow program. And for people who are interested, we have an internship program as well. So we would love to host you at our office, and we'd love to see if you're interested in the domain and you want to build a career into, and you want to learn. And then when you learn, you want to find employment in the space, we are open and we are ever inviting you.
Yeah, we are excited to have people like you join us and work with us. So if you like, you can visit our website, you can email us. You all have received an email from our team today regarding registrations and signups, right? Joining this meeting. You can always revert back to that email, or which is business@tensax.com on your screen right now, or visit our website, which is at www.tensax.com, and kind of get in touch with us about how you would like to join us. Regarding one more thing, we are going to continue with our webinar series now. So our next session details, we're going to share that with you shortly as we plan it out. And also, if you would like to kind of sign up for it, just revert back on the email that we send you with the certificates, which should be sometime on Monday.
All right. And we both enjoyed talking to you, and it was great. Thank you, Saurabh. We're happy to have you here, and we're happy to have you in future sessions as well. And for anything, any questions, any ideas, you can talk to us anytime. And I have to see you in our next sessions. We both will be there. And yeah, it was good talking to you this time.
Yeah, it was absolutely great, guys. Hopefully we'll see you in the next session. And yeah, this will be fun.
We'll see you next time. All right. Bye-bye. Session's out.
Bye, everyone.
Bye.